Okay, now we have to speak about magnetic field intensity at the center of a circular loop. For speaking about magnetic field intensity at the center of a circular loop, let us have a circular loop over here. Let this be our circular loop through which a current is passing in this manner. Let's say an I current is passing in this manner, and in this case the magnetic field intensity at the center of the circular loop. For that, let me have a point over here. This is the center of the circular loop, and you could clearly see the current passing through the center of the circular loop. It is it is clockwise. It is clockwise direction, and if the current is in the clockwise direction, by using our right hand grip rule, we could understand the magnetic field intensity is outwards. The magnetic field intensity over here is outwards, and we have to find out the magnetic field intensity. For that, let's say the radius of the circular loop is r. We will use Biot-Savart's law for finding out the magnetic field intensity. As you know, Biot-Savart's law is saying dV is equal to mu 0 by 4 pi I dl sin theta divided by r square. This is our Biot-Savart's law. For using Biot-Savart's law, we will have to mark a small segment of the conductor. Therefore, let me mark a dl over here, a small segment of this conductor. Then we can mark the r for this dl like this. This is the r for this dl, and you could clearly see dl is perpendicular to r. Then for another situation, let's say if dl over here is like this, the r will be from dl to this point, and this is our r, and in this case also you could say dl is perpendicular to r. Throughout the circular loop, we could clearly say dl, it is perpendicular to r. If dl is perpendicular to r, we could say the theta value, it will be what? 90 degree. As you know, sin 90 is 1. Rewrite this equation for dV as mu 0 by 4 pi I dl by r square. Okay, since sin 90 is 1. Then, how can we find out the total magnetic field intensity? From dV, in order to find out the total magnetic intensity, we will have to integrate this. Therefore, B is equal to integral of mu 0 by 4 pi I dl by r square. In this integration, we know we can take the constants out of this integration, and if we are taking the constants out of this integration, we could write B is equal to dl is the only variable in this, all the other terms are constant. Therefore, if you are taking all the constants out, mu 0 by 4 pi, that's constant, taken out. I, current passing through this is also constant, therefore taken out. R is also numerically a constant, therefore r square is also taken out. The remaining is integral of dl. Can you say what is integral of dl? Since integral of dl, it is the total length of the loop, that means the circumference of the loop. What is the circumference of the loop? We know it is 2 pi r. Therefore, we could write B is equal to mu 0 I divided by 4 pi r square into integral of dl, it is 2 pi r. Then we could cancel this pi and pi, 1 r and r square will get cancelled, 2 and 4 will get cancelled. Ultimately, we are getting an equation B is equal to mu 0 I divided by 2r. This is the expression for magnetic field intensity at the center of a circular loop. At the center of a circular loop. And in this case, the magnetic field intensity, it is what? It is mu 0 I by 2r. Okay. Then, for another situation, that is, if we are having an arc, let's say we are having an arc which is making an angle theta, and this is the current passing through the loop. For this arc, what is the magnetic field intensity over here? For this arc, the magnetic field intensity in this situation, it should be, in this arc, the magnetic field intensity in this situation should be what? Outwards. Am I correct? Yeah. In this case, if you are using the right hand grip rule, let me look. If the thumb is denoting the direction of current, then curled fingers will represent the magnetic field outwards. Yeah. In this case also, if we are using the right hand grip rule, if thumb is denoting the direction of current, the curled fingers, it will represent the direction of magnetic field, therefore it should be inverse. Okay. Then, in this case, we could derive up to this point in the similar manner. In the case of an arc also, we could derive up to this manner in the similar manner. Then, integral of dl in this case should be the length of the arc. Length of the arc. And as we know, r is the radius and this is the arc length. This length is arc length. This is angle. As we know, angle is equal to arc divided by radius. We know an equation, angle is equal to arc by radius. Therefore, in this case, we could write arc is equal to angle into radius, that is theta r. Therefore, the arc length in this situation, it could be written as theta r. Therefore, this equation can be rewritten as B is equal to mu 0 I divided by 4 pi r square into theta r. Okay. Therefore, this r and r square will get cancelled. B is equal to mu 0 I divided by 4 pi r into theta. This is the formula that we have to use for an arc of angle theta. Provided it's important that you should substitute the angle in its correct SI unit, that is in radian. Okay. Therefore, hope you have understood this.